Hi guys, meet the Pasco Mini Launcher, a compact yet powerful tool for exploring projectile motion in physics. This precision device is used in labs and classrooms to launch metal sphere, which is right on the top here, you can see, and at adjustable angles. So if you can see, the angle right now is roughly 40 if I'm reading it well, and you can always adjust the angle by using these knobs, and it can make it the angle up and down. It also the angle measurement I just mentioned, and 3 power settings. And the power settings you can see here, I have this one, and if I can have 3 clicks for this one, so power 1, 2 and 3, and then I can put this sphere inside, and which is ready for the launch. Here you can see exactly that one. Now students can observe and calculate how variables like launch angle and initial speed influence the trajectory. It's a hands-on visual way to bring kinematics equation to life. So the angle is 40 with 1 tick.
Hi guys, let's be doing the question on the projectile motion. This question has been taken from AP Physics 1, but I will try to just make sure just you understand the concept of the British curriculum and the IAB Physics as well. In this question, if you can see, we're talking about a soccer ball at rest on the ground, and they're asking time of flight, maximum height, and the range. If you want to understand question this well, if I can draw this diagram and you can understand that thing, this ball is rest at the ground and then being projected in this way, and this angle is 35 degree, and what we need to do, we need to know the time of flight of the ball, which is the total time that the ball is in the air. That's what we're talking about. And when the ball reaches maximum, this over here, if you have seen the video, and if you have seen the notes I have already placed with this one, it is vertical velocity drops to 0, right? Now here, and the maximum height occurs halfway, which is a halfway here, through its time of flight. The range, if you see this place here, the range of course is determined by the horizontal displacement during the time of flight. So that's the thing, you can analyze the whole thing what we is doing with this picture. Now what the first thing you can do here, you need to make data what is given to you, what they are asking here. That is very important to write it down. So we have got here initial velocity, which is v naught is equal to 12 meter per second. Remember that thing here in British curriculum, they say vi is equal to initial velocity, and sometimes they say v capital is the final velocity and u is initial velocity. So that's some sort of comparison we will do during the whole question. Then what is given to us? It is given to us angle, which is theta. So I can draw because it's difficult to write the angle. Theta is equal to given to you, which is I believe 35 degrees Celsius. So 35 degrees, sorry. So 35 degree is given to you, and we also have got acceleration due to gravity, which is minus c, because of course the ball will go down, as will go up. Its time of flight is going up, so against the gravity is equal to minus g, which should be equal to minus 10. It's actually 9.8, but we take 10 meter per second square. Easy to calculate. These things are given to us. Now we know the terms here. That's, for example, if I write here, if I draw a graph, for example, for x and y purpose. So this thing. For example, if I'm drawing vx here and vy here, this is the stuff. And then you know Vx is equal to always V cos theta, and we have Vy is equal to V sin theta. So V sin theta, Vy is equal to V sin theta. So what we do here, and why I'm doing the same, because we need to know that thing, what's the y component of the initial velocity. So if I go for the y component of the initial velocity, so if I take off this thing here and put in the corner for a while, and if I need to find out the y component of the initial velocity, so we say Vy naught, which is the y coordinate, is equal to, as I mentioned, is equal to V sine theta. And theta, again, I need to draw this thing, and I'll probably do it this way, it is easier. Sine theta. I'm sorry about that. This is theta, this is the angle here. Now, V sine theta, we know the same. So if we know what V we have got here, which is initial velocity for that one, and we have got V is equal to 12 meter per second here. So I just put the value of 12 meter per second and times sine, and theta value we have got 35. Very easy thing, you need to do it. You just need to start using calculator. Just put the value of sine 35, and which I am doing at the moment on my calculator, and that give me sine 35 is equal to 0.57 and times 12, which will be roughly 6.88. So my Vy naught is equal to 6.88 to 6.88 meter per second I have taken here. So that's, I've got Vy naught here. Now what I do here, because I need to use the right kinematics equation, so I know I'm doing the first question here, which is time of flight. This is our question we have here, time of flight. So we need to think about the equation which should have t in the equation. So if we go for all those three equations, I feel if I write here that Vy is equal to Vy naught and plus a, and it should be in the y-axis, at. I will write y down here, okay, and if you write here, so that's the equation we have to write here. And we know everything because we know that thing, that the final velocity of this that velocity of the y-axis, sorry, is equal to 0 we have got, and we have got this initial velocity for that one we just found it, which is 6.88, and we know a is equal to g, which should be is equal to minus 10, and I write in the bracket minus 10, and t we need to find easier for us. So it means what I can do, so 6.88 easy maths is equal to 10t, and t is equal to 0.688. That should be the answer in this one. So as we mentioned, I think I've got the value of the t is equal to 0.688 seconds here. Now what you need to understand here, because the time taken to reach the apex of motion is half the total time, so and because the motion is symmetrical, so total time of flight should be times by 2 this one. So t is equal to 2 times 0.688, and roughly I'm getting the answer 1.38 seconds. So my time is equal to, in this case, t is equal to 1.38 seconds. Now that's the first thing we have done it.